Hello everyone. Okay, lesson 6, trig. We're going to be looking at how to graph primary trig functions today. So sine, cos, and tan. And in particular, you and I are going to do sine of x together. And then in the assignment, you'll be creating the basic cos and the basic tan graph. So you have to do your homework, otherwise you won't know what that looks like. Okay, so periodic functions. Basically, a periodic function is a function whose graph repeats regularly over some interval of the domain. The length of this interval is called the period of the function, hence the name periodic. Okay, the amplitude of a periodic function is defined as half the distance between maximum and minimum values of the function. So we're going to look at in example 1 how to calculate period and amplitude just for some periodic functions that aren't necessarily sine, cos, or tan. All right, so looking at this first one, okay, period is basically the length of one cycle, okay, length of one cycle. So let's say start from the y-axis here. That'd probably be a good place to start. And if you follow this through, okay, where does it start to repeat? Right here. Here we go, cycle number 2. So from there to there would be the length of one period. And what would it be? It would be 8. So our period would equal 8. Okay, amplitude is basically half of the total range. So our total range would be whatever this value is. Okay, so from negative 10 to 10, or 10 minus negative 10 would be 20, divided by 2 would equal 10. So our amplitude equals 10. Okay, why don't you guys try B, and we'll see if we get the same answer. Okay, so pause your video and see if you can figure out the period and the amplitude of the next function. All right, pause your video. Okay, so did you get that the period was equal to 6? The length of one cycle horizontally is 6 from there to here. And the total range was 6 minus negative 2, which was 8, and therefore the amplitude would be half of that. So 8 divided by 2 is 4. So there's our amplitude, and there's our period. Okay, good. Why don't you guys try C as well, and then we'll see if we get the same result. Pause your video. Okay, so on this one, if you pick a point on the y-axis, follow it through. So at this point here, it starts repeating again, and there's another cycle. The length of that cycle would be 10, okay, so that's our period. The range of this graph is from 6 to 2, or 2 to 6, so we go 6 minus 2 is 4. Amplitude, half your total range, so 4 divided by 2, and we get an amplitude of 2. Okay, hopefully you got the same value there. Okay, so graphing primary trig functions, we're going to be looking at the graph of sine x, cos x, and tan x. In the lesson, we're looking at sine x, cos, and tan will be in the assignment. To investigate those graphs, we're going to use table of values method, okay, to graph each function on a domain of 0 to 360. And we're going to use the graphing calculator to complete the graph. Okay, so we're going to look at the graph of sine x. Okay, so we're looking at the next page, the exploration. Complete the following table of values for the domain 0 to 360. Give your answers to 2 decimal places where necessary. Okay, so that implies we can use the calculator, 2 decimal places. You could also get these values, the exact values, using your unit circle as well. But since the decimals might be a little more convenient for plotting them on the graph, we're going to be doing that. So we're using 0 degrees, 30 degrees, 60 degrees, so we need to be in degree mode. Make sure you're in that on your calculator, and you're just going to be simply going the sine of 0 degrees. Now we already know that, right? When you're at 0, coordinates 1, 0 from the unit circle, sine is your y. We know that's going to be 0. Okay, and we could get the exact value for 30 as well, but we're going to use the calculator now at this point. So sine 30 degrees on your calculator, go ahead and grab that, and we should be getting 0.5. Okay, 2 decimal places where necessary, we can leave it as 0.5. All right, so why don't you fill in the rest of those in the table, and then we'll check back, see if we have the same values. Okay, pause your video, please. Okay, let's check our answers. Take a look at this table, make sure we have the same values. What we're going to do now is plot those points on the grid below. Do not join the points yet, okay? So at 0 degrees, okay, so they labeled the axes and scaled them already for us. At 0, we have a sine value of 0 degrees. So really this y value is the sine of our angle, theta. Okay, and at 30 degrees, that'd be the first square. We'd be at 0.5. Okay, so we have 1, 2, 3, 4, 5 tick marks to get to 1. So 0.5 would be about at 2.5 tick marks, so we'd be about here. Okay, 0.87 at 60 degrees, that'd be the next square. 0.87, let's see, if there's 5 squares, each one would be about 0.2. That's 1 divided by 5. 0.2, 0.4, 0.6, 0.8, 0.87, somewhere in here. Okay, and at 90 degrees, we're now at 1. Okay, keep filling these in. Go ahead and plot those points, and then we'll check back and see if we have the same value. So pause your video, please. All right, hopefully we got the same points. It said do not join the points, so we'll just wait a minute on that. And now we're going to graph y equals sine x on the calculator using degree mode and the following window format. So here's your window settings. This would be y min, y max, and then that's your y scale. Make sure you're in degree mode again, and in y1 in your graphing calculator you're going to be putting sine of x. Okay, so I'm going to do that on the calculator as well, and we'll take a look at what that graph looks like. So yeah, pause your video, please. Okay, so we should have y equals sine x entered in y1. Check your mode. Oh, looks like I'm in radian. We need to change that to degree. Oh, went one too far there. Let's go up. Okay, hit enter on degree. Let's go to Windows, and we're going to change our window settings to what they have listed there. Okay, 540 for X max, and for scale 30 degrees. Okay, negative 1.2 for our y min, 1.2 for our y max, and the scale for y 0.2. Okay, we should be able to graph that now and take a look at it. And there we go, there's our graph. And this part in here agrees with what we plotted for points, so that looks pretty cool. Okay, so we're going to copy this graph onto our grid and then take a look at it. Okay, I'm going to do that, you do that as well, and then we'll compare answers, okay? Okay, so when graphing this, the one thing you have to remember is that you don't come up and do a V and then back down again. So try and put a little bit of curve into it, probably more so than I did here. Okay, so that looks pretty good. Did you notice that I was picking these points up by going, oh, negative 90 degrees? Unit circle, if I go negative 90 degrees, your sine value would be negative 1. So I knew where I had to go at what theta value, so that helped a lot. Okay, so a couple notes here. Sine is a periodic function whose graph continues indefinitely to the left and to the right. Yeah, we stopped our graph there, but that doesn't mean it didn't keep going. And so what we've graphed here is just a partial graph of what is actually there. So let's see if we can fill in these answers. State the following for the function where x is defined on a set of real numbers and is in degrees. Okay, so domain, obviously it goes forever, so we're going to say our domain is element of the reals. Amplitude, okay, so half of our total range. You'll notice it went from negative 1 to 1. Our range would be 2, so half of that would be 1. Our amplitude is 1 for that basic sine graph. X-intercepts, well, if we look back at our graph, our x-intercepts seem to happen at 0, 180, 360. Okay, so because they happened every 180 degrees, I would describe my x-intercepts as 180 degrees times n, where n is an integer. So what I'm saying there is if n is 1, I have an x-intercept at 180 times 1, so 180. If n was like negative 2, I would have an x-intercept at 180 times negative 2, negative 360. So that would cover all the x-intercepts. You remember like when we described the principal angle in terms of an unknown or a variable like n? Same idea. Okay, range. So it went from basically negative 1 to 1. So to write that in fancy math language, we go negative 1 less than or equal to y less than or equal to 1. Okay, we could also use interval notation, which would look like this. Negative 1 to 1 inclusive, so we use the square brackets. Okay, good. Period. So period is the length of one cycle. Let's take a look. How far we went from here to here, and then it started repeating. So it looks like the length of one cycle, or the period, would be 360 degrees. Okay, y-intercept. Let's go back, look at the graph. Looks like our y-intercept is 0. Okay, and there's only one of those, right? We only cross the y-axis once. Good. Okay, let's take a look at the next page. Okay, so a student was asked to reproduce the graph in Exploration B in radian mode. Okay, so we're doing y equals sine x, but now we're in radian mode. Write down the graphing calculator window format. So our window formats in degrees went from negative 360 to 540. So negative 360 degrees in radians would be negative 2 pi. Remember, one rotation, 360, is the same as 2 pi. So we'd be going from negative 2 pi, and then 540 degrees is basically 3 pi. And if you need to, you can multiply that by pi over 180. Sorry, pi over 180 to get the value in radians to convert that. So we're going from negative 2 pi to 3 pi. Our tick marks, we could use what they had. 30 degrees is the same as pi over 6. Okay, and y, we'll keep that as negative 1.2 to positive 1.2, scale 0.2. Okay, sketch the graph of y equals sine x for 0 to 2 pi, showing the intercepts. Okay, and probably what we'll do is we'll write down a little equation to represent the intercepts. All right, let's grab the graphing calculator and do that. Okay, so we don't need to put a different equation there. We're fine. We do need to change mode, so go down and change to radian mode. And then our window settings, oh, look at this funky graph we're getting over here because we haven't changed our windows yet. What we could do, here's a really good way to change your window settings quickly. If you go zoom trig number 7, it will automatically change your window settings from basically one cycle, negative 2 pi to the left and positive 2 pi to the right. Check out your windows. That's approximately negative 2 pi. Now, they wanted from 0 to 2 pi, so let's just change that to 0 and 2 pi. But remember that for a quick window settings, okay? And this is pi over 2, but we wanted pi over 6, so we'll go pi divided by 6. And don't worry about the fact that it changed it to a decimal. That's what the calculator does. Negative 1.2 to positive 1.2 and 0.2 for your tick marks. Okay, so take a look at the graph. Lovely. All right. Now the intercepts. Looks like our y-intercept is still 0. We could check that by going trace, type in 0 for x, and sure enough we get y equals 0. And our x-intercepts appear, this is 30 degrees. Oh no, this is pi over 6. It appears to be at pi and 2 pi because remember our scale went from 0 to 2 pi. Okay, so let's see if we can write down those intercepts. Y-intercept is going to be 0. Our x-intercept, let's see if we can come up with that generically. It seemed to be happening at every pi. Okay, so to write that we would go pi times n, where n is an element of the integers. Okay, that way we're getting every pi as our x-intercepts. Good. Okay, so go ahead, you can do the assignment now for lesson 6 in class, and we're going to resume, we're going to be doing lessons 6, 7, and 8 all in tonight's homework, so go to part 2 or lesson 7 to continue with your videos. Thank you, and we'll see you in lesson 7.